where I want to go. Woohoo! Welcome back. Tonight we're going to be talking about lines. And to start with, we should talk about what a line is. When I say line, I mean one of these. Now this happens to be a horizontal line. There are vertical lines and diagonal lines and all sorts of different kinds of lines. But when I'm talking about a line, I'm referring to the mathematical concept, which is one of these stick guys with arrows on both sides, signifying that it keeps going infinitely, both directions. I should point out that if you're thinking of one of these that has dots at the ends, this is a line segment. It's a piece of a line, but it's finite. Well, the length is finite, and it starts and ends at these points. So when we talk about lines, we mean they head off in both directions forever and ever. And if we're thinking about lines, the next thing we should talk about is, how do you get a line? What does it mean to be a line? And so the question comes up, what makes and or describes a line? And I'm going to claim that if you have 2 points, any 2 points, whatever 2 points you pick, as soon as you have 2 points, there is a single line that passes through those 2 points. Or you could just have 1 point and then know that you want to head off in, say, this direction. And as soon as you know that, then you have also described a line. In math, the direction that the line heads in is also known as the slope. So, fun fact, if you have 2 points, there's only one line which passes through both of them, which is really convenient because that means I can give you the coordinates of 2 points and have you find the line that passes through them. Yay, super fun stuff. And if you are given those 2 points, you will also be able to find the slope of that line. So let's talk about what slope is. Basically, the slope is a measurement of how steep a line is. And I've created, a handy dandy little card to help us with what a slope is. Ooh, slope of a line. Let me get this in there. Woohoo. So the slope of a line, you can see I've drawn triangles, and that's to help us understand what the slope is. So here's the line right here. This is the line, and this line has a positive slope. It is going up. And I know it's got arrows going in both directions, so people say, well, which way is up? But basically, if it's tipped this way, that slope is considered going up, so it's positive. Why do we do it that way? Well, in general, when we read graphs, we read from left, right? This side makes the L, to right. I can't make an R with this one. I mean, I can make that R, but I can't make an actual R. So we start on the left side and we read left to right. And so because of that, a line that looks like that is heading up. And then a line that looks like this is heading down. So we assign this a negative slope. This has a positive slope. And we have the concept of the run and the rise. So if you pick any 2 points on the line, and then you look at how far, if you start at 1 point, you move in the X direction, that's considered the run. And then you move up or down, that's considered the rise. And you take the ratio, the rise over the run, you get the slope. And you'll notice I've used the secret letter M. M stands for slope. There is a fancy formula. We're going to talk about this, how to use it. And then there's also this really cool way of writing it, which is very simple. You write a triangle, which means the difference in the y's. So how much does y change? And then triangle X means how much does X change? And we're going to talk about how to use that. So this is our handy dandy little card. I'm going to move it to the side here till we need it again. But let me write down in the notes. So slope is usually represented by m, or you can just write out slope. A lot of people use the rise over the run to remember, and I'll remind you that the y's rhyme with the rise. So rise and y's go on top. So this is going to be y2 minus y1 over x2 minus x1. Now, does it matter which is which? Not really. What really matters is that the x's and the y's have to match up. So these x and y go together, they're from the same point. And this x and y go together, they're from the same point. And again, as I have on the card, we can use the fancy Greek letter delta. Delta y over delta x means the change in y all over the change in x. And now, right now, this is going to feel like, hopefully you've seen this before, you've heard it before, you're feeling like, okay, yeah, I've heard this. This is the thing with lines. But it turns out that this right here is the foundation for calculus, believe it or not. This is so important. Slopes are so important in mathematics. It becomes this whole giant piece of math. So this is something that hopefully feels pretty comfortable, or at least it will when we finish, but in fact is very, very powerful. So don't forget this. Make sure you have this written down somewhere so that you can refer back to, or you have these notes. So let's talk about how we're going to use this in this class. So the way we're going to use this is we're going to go ahead and take, remember the 2 points. I said I could give you the coordinates of 2 points and you could find the slope of the line passing through the 2 points. So we're going to start off with 0, 0, the origin, and 2, 2. And we can use any of these definitions to do this. But I'm going to focus on this right here. So my slope is going to be y2 minus y1. Now, which one is y2? You know, you can choose either one. You can start with either y. So I'm going to go ahead and choose the 2. So I'm going to choose 2 minus 0. Now, this is a little confusing because it turns out that the y, that's 2, corresponds to the x, that is also 2. So we get 2 minus 0 over 2 minus 0. Okay. So that ends up being 2 over 2, which is 1. So the slope of this one is 1. Some people will ask, wait a minute, what if I didn't start with 2? What if I started with the zeros, the origin? Okay, that y is 0 minus 2. And then the corresponding x's are 0 minus 2, at which point a lot of people are like, see, this is going to give you a different answer. And the trick here is because you're taking a ratio, even though you get negative numbers, they're both negatives. And remember, just like this becoming a plus, a minus over a minus also becomes a plus. And so we get positive 1. Same answer. I just wrote the one slightly differently. This is a fancy one. I should write this one fancy. There we go. Woohoo! Okay, let's try another one. Now that one was perhaps not a great place to start because the x's and the y's match. So let's talk about a couple of points where the x's and y's are different. So I've got 0, negative 1, and negative 2, 3. And again, for my slope, I'm going to go ahead and start with one of the y's. So you could choose negative 1 or 3. I'm going to choose 3. As soon as I choose to start with 3 in the numerator up top, I have to start with 3's buddy, which is negative 2 in the bottom. So if I were to, let me see if I can do this without completely obliterating the numbers. But if I start with this point, you'll see I start with these 2 values. And then I'm going to subtract top and bottom, right? I subtract the y's, I'm sorry about that, I subtract the x's. So if the other point is, oh my goodness, these are stuck on really hard today. If the other point is yellow there, then the corresponding y value is a -1 and a 0. And I put parentheses around this so I don't see a minus minus. It's just a little easier. You don't have to. You could do a minus 1 if you'd like. So if I do it this way, I get 3 minus a -1, or 3 plus 1, all over -2 minus 0. So I get 4 over -2, and so the whole thing is -2. Well, what if I reverse the order? What if instead of starting with the 3, I start with the -1? So I take -1 first. That means in the denominator, I'm going to start with 0 first, and I'm going to subtract the other ones. So -1 minus 3 over 0 minus a -2. That's going to be a -4 all over a +2, and I'm still going to get a -2. So I get the same answer regardless of which order I do it in. And the reason for that is because this is a ratio, which is really nice. You know, a ratio. I knew him. Okay, so this last one, oh no, this is fractions. And it's going to be super fun. Yay! Okay, I've got 0, 1/2, and for some reason Microsoft Word is like, now I'm too tired. So they didn't format that one, 1/2 too. Yay, let's hear from Microsoft Word. Okay, so the slope equals. Now, if you're going to choose to do slope, I would always encourage you to consider which numbers are bigger. These two are greater than these two, so I'm going to start with this one. So the y on top I'm going to start with is 2. So the x on the bottom I'm going to start with is 1/2. And yes, it's weird looking to have halves inside a bigger fraction, but I'll show you what to do if you don't quite remember. And then I'm going to subtract 1/2 on top and 0 in the denominator. And I'm very excited about 0 because 1/2 minus 0 is just 1/2. I don't have to do any hard work here. However, I do have a problem up top because I'm going to have to do 2 minus 1/2. And so there are a couple different ways to work this out. I'm going to take some space right here, and I'm going to remind you that 2 is really 2 over 1. And I can write that in halves. And let me see if I have my red pen of destiny. So to get from 2 over 1 to halves, I multiply the bottom by 2, and I'm going to multiply on top by 2. So I'm going to get 4 halves. So I can convert the number 2 to 4 halves, and then I've got 4 halves minus 1/2. Right? So that's going to be 3 halves all over 1/2. Now, if you are like most people, fractions, oh my goodness, fractions, am I right? Yeah, so if you would like a review of fractions, you are welcome to look at my other videos. There are tons of videos online, but you're also welcome to come to me or go to the tutors, and we're all happy to help you out. You say, I would like to practice fractions, and we'll probably say, what kind? Do you want to multiply or add them? Do you want to convert them? And, you could always bring in the notes from this and say, I want to do this. And then we can come up with examples and work through them till you feel comfortable with it. Woohoo! So, speaking of comfortable, this is not a final answer, right? This is a fraction on top of another fraction. There are a couple ways to deal with this, but since it's a single fraction on top and a single fraction on the bottom, you can actually just rewrite this as a division problem. And then remember, when you're dividing a fraction, you can flip the second fraction. So it becomes 3 halves times 2 over 1. Remember, you flip it, flip the second one, and 3 halves times 2 over 1, I can cancel these 2's since it's multiplication, and I get that the slope is 3. Yay! Woohoo! Are we excited? I hope we're excited. Okay, so this has just been the first part of the review of lines. We're just working through how to find the slopes. In the next video, we're actually going to be taking what we know about slopes and going ahead and applying it so that we can come up with full equations of lines. I know, I'm very excited. Godzilla's very excited. You guys enjoy a little break, get some water, get a snack, go out and look at something green, and come back and we'll talk about lines. Woohoo, math on, and woohoo.